Hello everyone. Great. Good evening, everyone. So this one here, this one here, right? Okay, great. So guys, today we will be learning about. Okay, in the yesterday session we have learned about linked list, right? Okay, what is linked list? What is the difference between array and linked list, right? And we have seen how we can traverse the linked list, how the information gets stored behind the scene, right? In the linked list, we have to create user-defined data type, that is our class, and in that class we have to define the data members, right? One data member to store the information of data, and the next data member to store the information of the next address, right, everyone? Yes or no? After that, we have seen how we can traverse through the linked list, right? Yes or no? With the help of while loop, we are traversing through the linked list, right? After that, we have seen the insertion operation, right? That is insert at head and insert at tail, right? So guys, today we will be learning about inserting the element at the kth index, right? And after that, the agenda of today's session is like insert at the kth index that we are going to learn. And after that, we are going to learn about deletion, that is deletion at the head, tail, and at the kth index, right? And after that, if we have time left, we will be learning about some questions related to linked list. Okay, how to solve that question with the help of recursion, and how to solve that question with the without using recursion. Okay, because we have learned about recursion, we know the base of recursion, right? So we will try to implement recursion also here, right? Yeah. Hmm. Great. So guys, everyone is ready now? Please give a thumbs up if this is clear. Yes, everyone. I can see less excitement in the chat. Okay, great. Great, Surya. So without wasting our time, let's start the session, right? So let me again walk through the code that we have discussed yesterday. And after that, we will continue with the remaining part of the code, okay? Can you guys please confirm in the chat, my screen is visible, right? Or should I increase the font size? Everyone present in the class. Should I increase the font size or it is visible? Mm, you're right. Let's increase the font size, right? A little bit. That is this one. Now it is clear? Okay, great. Hmm. So guys, we have the main function, and inside the main function, we know how we can take input from the user, right? This we have discussed yesterday, right? How to take input from the user. So for taking input from the user, you can see guys, what we have done. First, we have created the blueprint, right? Okay. First, we have created the blueprint of the node, right? How to create the blueprint? With the help of a class. And in the class, you can see guys, we are having two data member, one to store the information of data and the second to store the information of the address of next node. Since we have to store the information of address of next node, that's why the second data member is what, guys? The second data member is a pointer that is of node type. What does it mean? Next is the pointer that is holding address of node, right, everyone? After that, what we have done here, that is at line number 8 to line number 11, we have created a constructor. And what is constructor? Constructor name is same as the class name, right? It has no return type and it returns nothing. And the main task, the main objective of using constructor is what? To initialize the data member, right? This is clear. After that, we have this take input function, right? Hmm. Let me increase the size a bit more so that everyone can see the text, right? Zoom in. Okay, great. This one here, right? Hmm. Hmm. After that, guys, here you can see what I've done. Here I'm creating a variable to take input from the user and to store the information inside the variable. So for that reason, I'm creating one variable of integer data type. Okay. After that, here I'm printing a message on the console. Okay, you have to take input from the user, and if you want to exit, right, then press -1. Right. After that, what we are doing, we are just printing a message ki, hey, enter data in a node. Right. After that, we are taking a data, and that data we are storing where inside the data variable. And after that, here you can see we are using a while loop, and this while loop will work till the time data is not equal to -1. Right, everyone? This is clear. And at line number 22, we are creating a new node, right, by using the object. Right, how to create the object, that we know, that is the class name. After that, the reference variable name is equal to new keyword is responsible for allocating memory inside the heap, right, like this. And after that, you can see, guys, we are connecting it, right? We are doing the connection here. Okay. And similarly, you can see the print function. In the print function, we are iterating, right? And yesterday we have seen that is why we have to use head not equal to null, and why we have to use head not equal to null, and why head next not equal to null will not work, right? Yes or no? This is clear. And after that, we are printing the data and we are moving to the next node, right? Like this, we are printing the whole data, right? And here I should preserve the address also. Okay, so I have done a small mistake. That is what I will do. I will preserve the address of the head node. That is equal to head here. And here I will take temp, right? Temp ka data here, temp ka data here, and here also temp, right, everyone? This is clear. Print function is clear, everyone. After that, this print function here. And after that, guys, what we have learned? We have learned about the insert at head, right? How to insert the element at the head part. That is, we have created a new node, right? And after that, we are connecting the new node at the head part. And now my new node is acting as a head node, right, everyone? Now my new node is acting as a head node. So that's why I'm returning this new node. This also we have discussed. After that, we have discussed about the insertion at tail. So to insert at tail, we have to traverse and we have to stop at the last node. So to stop at the last node, we have to use this condition, that is temp next not equal to null inside the while loop. Right, everyone? Yes or no? To stop at the last node, we have to use temp next not equal to null. Okay. After that, here, right? This one, this one, this one. And after that, after the while loop, you are standing at the last node, and after that, you are doing the connection. Right? Great. So now let's move to the next part. That is what we have to do now. We have to insert an element at the kth index, right? And our indexing start from 0, let's assume. Okay. So let's take one example so that you get the more clear understanding here. That is what we have to do here. The next question is, okay, and those who are not able to connect with these questions, okay, these questions we have discussed, this whole problem statement we have discussed in the yesterday session. Okay, everyone. So if you are not able to understand anything, you can watch the recording of the previous session. You will get the clear understanding what we are discussing right now. Okay, great. So now here, so let's move to the next problem statement. That is question 1 here. What we have to do, we have to insert a new node at the kth index, right? Insert at kth index, right, everyone? This one here. Great. So here, let's take one example, right? So let's assume I have a linked list here, right? That is this one. I have already created a linked list. That is this, this, and this, right? And let's put some data also inside the node. That is, let's assume the data is 7. Here the data is 9, 5, 11, and 1 here, right? This is my linked list, right? Everyone understand this point? And the head is holding what? Head is holding the address of the first node, right everyone? Head is holding the address of the first node here, and this is zero based indexing, right? Okay, zero based indexing. So what we have to do, we have to insert a new node at the kth index. Let's assume k is what? K is 2, right? So we have to insert a new node at the second index. So here, this is 1, this is 2, 3, 4, right? Everyone is getting the point. So this is the second index, right? So at this point, we have to insert a new node. Let's assume the new node is this one, right? And let's assume here we have the data is 17 here, let's assume. Okay, this is my new node, right? This one is my new node, right? So guys, now I have to insert this new node between 1 and 2, right? In order to insert the new node at the second index, right, at the kth index, you have to insert this new node between this 1 and 2, right? Yes or no? This is clear. So guys, how to do this part now? Let's see. So if I will, like, let's give some address also, so that you get the more clear understanding here, right? So let's assume the starting address is 700 here. It is 802. Let's assume this is 912. This is 1020. This is 2040. And the address of the new node is, let's assume it is 4040. Okay. And here, this is holding 802. This is holding 912. This is holding 1020. This is holding 2040. And here we have null, right? And here also we have null, right, everyone? So guys, in order to insert this new node between 1 and 2, between index 1 and index 2, right? That is between the node 9 and node 5. I have to do some connections, right? Right now, this 9 is doing what, guys? 9 is holding the address of node 5, right? 9 is holding the address of node 5. So what I will do first, okay, what should be the first step, guys? Okay, let me give you two options here. That is, option A is, first what I will do, I will connect this 9 node, right? I will connect this 9 node with the new node, right? Okay, like this. So this is step one. That is, first I am doing a connection of 9 node with this 17 node, right? And after that, I am connecting this 17 with 5. That is, this is step second, right? And option B is, we have this 9 node, right, everyone? Here, we have this 9 node and we have this 7 node, that is our new node, right? New node. And we have this 5. So this time, what I will do, first I will make this connection. That is, I will connect this 7 node with the 5th node, right, everyone? I will connect this 7 node with the 5th node. This will be my step 1. And after that, I will connect this 9 with 7. This is step 2. So guys, please write in the chat. And steps option 3 is what? Option 3 is none of the above, right? None of the above here. And option D is don't know the answer, right? Don't know here. So guys, please write in the chat which option is correct. Please write in the chat. Question is clear now? Yes, everyone. Which option is correct here? Please write in the chat. In option A, first we are doing this connection. That is, we are connecting 9 with 17. And after that, we are connecting this new node with 5. This is second connection. And at option B, first we are connecting this 7 with 5, and after that we are connecting 9 with 7, right? Yes, everyone. Anyone? So guys, here I can see no one is responding. So let's discuss both the options so that you get the more clear understanding here, right? So see here, if I will go with option A, right? If I will go with option A, then what will happen here? So here what we are doing, you're saying, ki, okay, first connect the 9 node with the new node. How you will do the connection? If in order to connect this 9 node with the 17 node, you have to store the address of the new node inside the 9 node, right? Yes, everyone. So here in this place, you have to store what? You have to store the address of new node, that is 4020. And the moment you will update the address part inside the 9 node, you will lose this address, right everyone? We will lose this particular address. If I will connect the 9 node with the new node, you can see guys what we are doing in the next part of 9, we are storing 4020, and the moment I will store 4020, I will lose the address of this 5 node. And if I am losing the address of any node, that means I will never be able to access that particular node, right? Yes or no? So here in this case, we will lose the address, lose the address of node 5. And the moment I lost the address of node 5, that means it is not possible for me to connect this new node with 5 again, because I don't know the address, right? I haven't stored this address anywhere. Everyone is getting the point? Yes or no? Great. So the first option is clear, right? Why we can't go with the first option? Because if I will connect this 9 with 17, I will lose the address of 5, and it is not possible for me to connect this new node with 5, right? Okay, great. Okay, let's see the second option, right? This one here. Second option. In the second option, guys, first what we are doing, we are making this particular connection, right? We are making this particular connection, that is we are connecting this 7 with 5. Okay, in order to connect, in order to link 7 with 5, what I will do? 17 with 5, okay, not 7, 17 with 5. In order to link 17 with 5, I have to store the address of 5 inside 17. So here I will store the address of 5 here, right? That is 912. The moment I will store the address of 5 inside 17, I have done a linking here like this, right? Everyone is getting the point? Yes or no? And guys, you can see while doing this linking, I am not losing any address, right? While doing this linking, I am not losing any address. Right now, I'm standing here, that is at index 1, right? Right now, I'm standing here at index 1, and first step is what? What I have done here? I have linked the new node with 5, right? This is clear. Now I have to do this connection, right? Now I have to do this connection. So how to do this connection? To store the address, like here, let's assume this is temp, right? So now I can update the address part of 9. That is, now I can store here 4020. The moment I will store 4020 inside the 9 node, I will break this connection, and this connection will be established. Right, everyone? This is clear. And you can see, guys, if you're breaking the connection now, breaking the connection between 9 and 5, you can see the address of 5 is still stored here, right? Because you have performed this operation first. That is, first you have connected this new node with 5. So you are not losing the address, right? So option B is the correct answer. Right, everyone? This is clear. Option B is the correct answer here. Everyone is getting the point. So let me write the step. Step number is what? Step number 1 is traverse the linked list. Okay. Okay. Traverse the linked list and stop at k minus 1 index, right? K minus 1 index. You can see, guys, where I am stopping, where I am standing right now. I have to insert the new node at index 2. So I'm stopping at index 1, right? Everyone is getting the point why I'm stopping at index 1, so that I can do the connection. If I will stop at index 2, then it is not possible for me to connect with index 1, right? Then either I have to use an extra variable, then the algorithm will become more complex, right? So that's why the simple step is what? Stand at k minus 1 index, right? So here, traverse the linked list and stop at k minus 1 index. So now you are standing at the k minus 1th index, right? After that, second point is what? Connect new node with kth index node, right? Kth index node, right? This will be the second point. Everyone is getting the point. That is, we are doing this particular connection. This is k minus 1 index node and this is your kth index node, right? So if you are standing at, right, why I'm stopping at k minus 1 index, guys? Why I'm stopping at the k minus 1 index? So that you can see, guys, if you're standing at k minus 1 index, you can access the kth index also. You know the address of kth index also. And if you are standing at the kth index, then it is not possible for you to access the k minus 1 index, because you don't have any information. If you're standing at index 2, you don't have any information of index 1, right? So that's why we are standing one index before the insertion, right? And third step is what? Now connect, okay, connect your k minus 1th index with new node, right? New node here. And guys, while doing this process, you have to take care of, okay, take care of null pointer exception. See this point also, null pointer exception you have to see, right? Let's see with the help of code, you will get the more clear understanding, okay? But I'm assuming, guys, you are able to understand the process, right? Process is clear. Everyone present in the class, those who have attended the yesterday session, they will be able to understand the current session also, right? But yes, the process is clear. Yes, everyone. Okay, great. So let's see now. Let's try to implement in the code also. So here, this one here, this one. So here, let's write the code here, right? Hmm. Hmm. That is, we have this node, right? Okay, we have to insert the element at the kth position and we have to return the header node, right? That is, let me write the comment also, function to insert a new node at a given index in linked list, right? So here, node star insert at kth position, right? Kth position here, and insert at kth index, right? Not position, kth index here. And after that, in this function, we are getting the start of the linked list, starting address of the linked list, and that address is stored inside the head pointer, right? Node star head. And after that, we are getting the new data, right? That we have to insert at the kth index, and we are getting the index also, right? That is int k here. Okay, everyone, this is clear now. And after that, what I will do, the first step is what? You are getting the data. First, you will create a new node, right? How to create a new node? Just create the object, right? That is node star new node is equal to new node. And here we have this. Inside this, we have to pass new data, right? Yes or no? This is clear. So we have created a new node at line number 72, right? Okay. After that, after that, what I will do, guys? Okay, I have to preserve the address, right? In the yesterday session, we have discussed whatever computation you are doing on the linked list, always preserve the address of the head node, because if you have lost the address, you will never be able to come back again, right? So I will preserve the address, that is node star temp is equal to head, and whatever operation I have to do, I will perform the operation on the temp node, right? This is clear. Okay, now what I will do, I have to traverse the linked list, right? And I have to stop at which index? I have to stop at k minus 1 index. So I will use a for loop, and since this is a zero based indexing, so I will start from int I is equal to 0, I is less than k minus 1, I plus plus, right everyone? This is clear. And what I will do, I will just iterate, that is temp is equal to temp ka next, right? Temp is equal to temp ka next here. Okay, so let's understand this for loop here, right? So that you get the more clear understanding. So here, this for loop we have, right? So how this for loop is working, let's understand that part also. That is, we have this, 1 minute. Let's assume this is my linked list, right? This one here, this one here, and this one here, right? And your temp is what? Right now, your temp is pointing to the first node of the linked list, right? This is a head node, and this is temp also, right? This one here. And let's assume k is 2. So where we have to stop? We have to stop at k is equal to 1, right? So here, right now you can see guys, for loop we have, right? For loop we have. So first, this this initialization part will take place, that is I is equal to 0. After that, you will move to the condition part. 0 is less than 1. Yes, 0 is less than 1. It is true. So you will move inside the body of the for loop, and you will execute this command, right? This instruction you will execute, that is temp is equal to temp ka next. So from here, now you will move to the next node, that is now you are standing here, right? After that, the value of I will get incremented. Now the value of I is what? 1. 1 is less than 2 minus 1. 1 is less than 1. No, it is false. So you will move out of the for loop, right everyone? The moment the condition is false, you are moving out of the for loop. And now you can see guys, the current state after the for loop, the current state is what? This temp is where? This temp is pointing to the k minus 1 index, right? This temp is pointing to which index guys? It is pointing to k minus 1 index. This is clear everyone? After that, here, right? After that, what I have to do? I have to do the connections, right? I have to do the connections. So how to do the connection guys? First, what I have to do? This one here. This is temp, right? And this is my new node, right? This one, this is my new node here. So first connection is what? I will connect new node with this kth node. So how to access the kth node? How to access the kth node guys? I'm standing at k minus 1 node, and this is the kth node. So how to access the kth node? Inside this temp node, you can see inside this temp node, the address part is holding the address of the kth node, right? That is clear, yes or no? So here, if I have to take an example that is like this, you can see if this is 800, so this 800 will be stored inside this k minus 1 index node, that is inside this temp node, right? Everyone is getting the point? So if you're standing at the temp node, you will be able to access the kth node, because in the temp node, in the address part, this address is stored of the kth node, right? So here also, first I have to make this connection, that is new node I have to connect with the kth node, right? So what I will do here, that is new node car next is equal to temp car next, right? Temp car next. So why I have written this line? New node car next is equal to temp car next, right? So here, new node car next is equal to temp car next here, right? So right now temp is what? This one. And temp ka next is holding what? It is holding 800. We have the assignment operator. Right hand side part will get executed first, right? So here we will get 800, right? And now where we are storing this 800? In the left hand side part. In the left hand side part, in the new node, in the next part, that is here we are storing 800. The moment I will store 800 in the address part of new node, that means I have connected the new node with the kth node. Everyone is getting the point? Yes or no? Now what I have to do? I have to make this particular connection. That is this connection. I have to connect the k-1 index node, that is your temp node, with the new node. How to connect it? That is, you have to store the address of new node inside this temp ka next part, right? So new node is a pointer that is holding the address of new node, right? So you have to just write this command, that is temp ka next is equal to new node, right? Everyone, please write in the chat till this point anyone has any confusion. Please write in the chat if this is clear. Yes or no? Yes, everyone. Any line, guys, you are not able to understand? Yes, no, anything, guys, please write in the chat. If you're attending the first class, then you have to go and watch the previous recording so that you get the clear understanding of LinkedList and all the other stuff, right? So if you will directly jump to the LinkedList without understanding the LinkedList concept, class and object concept, you will get confused. So only Sujit is saying clear. What about others? No one is asking any questions. Okay. Just I am talking to myself only, right? Yes, it is available. Okay, great. So now, see, but okay, everyone is saying it is clear, right? So everyone, okay, when you're learning something, right? First focus is like when you're learning something. I can see most of the students are saying how to mark the attendance and how to generate the certificate and all. Guys, again, everything is like it is not a important thing to mark the attendance and this certificate and all, right? Skills is important, right? If you have the right skills and if you're not having the certificate also, they will not see your certificate, okay? They will see your skills, how much you know about anything, okay? How much in-depth knowledge you have. So always try to focus on the skill set, okay? This is the first thing. The second thing is what? When you are learning something new, right? Okay, or you have learned from somewhere, try to ask questions, okay? The more you will ask the question, the more interactive the class will be, okay? Everyone is getting the point? And try to like ask yourself also why you have done this thing, okay? Why you have written this thing? Is this code is correct, or this code will fail somewhere? Is there any test case where this code will fail or not? So you have to think in all the direction. When you are learning something or when you are implementing the code, you have to understand ki, okay, this code will work. What if the linked list is zero? The length of the linked list is zero, that is there is no node present in the linked list. Okay, tell me guys, if your head is null, okay, if your head is null here, that is this one, head is null, can you guys tell me this code will work if your head is null? Please write in the chat. There is one test case where there is an empty linked list. No node is present, right? In that case, this code will work, everyone present in the class. This code will not work, right? Because you can see, guys, right here. Here you can see you are doing what? Inside temp, null is stored, right? Inside temp, what we are storing, guys? We are storing null. And after that, at line number 80 or at line number 77, what we are doing? We are doing null connect, right? Null connect. And if there is nothing present, then how you are able to access this next, right? Next is not there. So you will get null pointer exception, right? So you have to be very careful when you are using this temp connect. You have to see the null case also, right? So here what I will do, I will write a check. If, right, if your head is equal to null, that means what? That means this is your first node, right? This new node is your first node. And since it is the first node, it will act as a head node, right? So return new node from here, right? This is clear. And here also what I will do, see, after doing the connection, I will return the head, return head here, right? So guys, now if this is clear, tell me guys, is still I am missing anything? Everyone present in the class. If this is clear, still I am missing anything? Any test case where my code will fail? Tell me guys. Any test case where my code will fail? Anyone? Yes. No. Still there will be one case where my code will fail. What will be that case? Try to think. See, if the value of k is 0, right? If the value of k is 0, k is 0 here, right? In that case, guys, what we are doing, let's see. In that case, if the value of k is 0, that means we have to insert the node at the start itself, right? So first we are creating a new node. After that, we are checking whether the head is null or not. If the head is null, that means this is a new node, then everything is good. But if the head is not null, then we will go here, that is at line number 79. We are storing the head information inside the temp, right? We are storing the head information inside the temp. After that, at line number 80, we are doing what, guys? We are traversing to the k minus 1 index, right? That is I is equal to 0. And right now the value of k is what? 0. So 0 minus 1 is what? Minus 1. So 0 less than minus 1, it is false, right? So here you can see if the value of k is 0, then this will be 0 less than minus 1. And this is false. And if this is false, you will never go inside the body of for loop, right? You will move out of the body of for loop. And after moving out of the body of the for loop, what we are doing? We are saying new node ka next is equal to temp ka next, right? Temp is what? Your head, right? Temp is your head here. Everyone is getting the point, yes or no? And after that, again, you are doing temp ka next is equal to new node, right? So this kind of thing will happen. According to our problem statement, if this is the case and the value of k is 0, right? So here k is 0, that means we have to insert the new node at the start itself, right? That is here itself, that is here, right? So what we are doing here, that is right now we will not move inside the body of for loop, right? So here after this, what we are doing, we are saying new node connect is equal to temp connect. That is, we are making this particular connection first, right? New node connect is temp connect. So we are making this connection first. After that, what we are saying, we are saying temp connect is equal to new node. That is, temp is this one and temp connect is equal to new node. We are making this particular connection. And the moment I will make this particular connection, that is temp ka next is equal to new node, I will lose the connection of all this node, the second node. And the moment I will lose the node, the moment I will lose the address of the second node, I will never be able to access it, right? So I have to be very careful when the value of k is equal to 0. So guys, here what I will do, I will write a explicit check for k is equal to 0. That is, if k is equal to 0, in that case, I will directly connect my new node with the head, right? That is your temp. I will directly connect my new node next is equal to head, right? And now since this new node is acting as a start node, so from here I will return new node, right? Now this new node is acting as a start node, that is the head node, right? This is clear. Everyone present in the class, this is clear. Okay, please explain line 80. Line 80. So this one, this for loop, right? Okay, this for loop, Tashi. Yes, this for loop you're asking about. Hmm. Okay, great. So let's see line number 80, what I have done at line number 80, right? Again, this part, right? Hmm. So we have this linked list here, right? This one here, this one here, this one here, and this one here, right? And since this is a zero based indexing, so this is 0, 1, 2, 3, and 4. And let's assume the value of k is 2 or 3, let's assume. The value of k is 3 here. And we have to insert a new node at index 3. That means we have to insert a new node here. Okay, here, in between 2 and 3. This is clear. Okay, so now I have two options, right? See, I have two options. Either I can stand here at index 3, or I should stand here at index 2, right? Let's see if I will stand at index 3, what disadvantage I will get if I will stand at index 3. So if you will stand at index 3, then guys, you know the information of index 3 node, and you know the information of index 4 node, but you never know the information of index 2 node. You guys are getting the point? Yes or no? This is clear? Yes. So if you're standing at index 3, that is at the kth index, this is the kth index. If you're standing at the kth index, you know the information of the kth index, you know the information of k plus 1 index, but you will never know the information of k minus 1 index. This is clear. And right now in our problem statement, we have to do these connections also, right? That is, we have to connect k minus 1, that is index 2 node, with the new node, right? And since we don't know the information of the k minus 1 index node, since we don't know the information of the second index node, this connection is not possible for me, right? This connection is not possible for me. So what I'm doing, I'm not directly standing at the kth node. What I'm doing, I'm saying, okay, I will stand at the k minus 1 index node, that is at index 2. And if I'm standing at index 2, guys, you can see you are able to access the k minus 1 index node, you are able to access the kth index node, and you know the information of new node. So you can connect your k minus 1 index node with the new node, and you can connect your new node with the kth index node. Now this is clear. So that's why I'm using a for loop that is traversing from 0 and k minus 1, less than k minus 1. Okay, so Tashi is asking this question. Okay, now this is clear. Everyone present in the class, now this is clear. Please give a thumbs up if everything is clear till this point. Okay, yes, no. Okay, great. This is clear now, right? So guys, again try to see the pseudo code here, right? And tell me, still I'm missing anything? Anything guys, we are still missing here? Any test case where my code will fail? Anyone? So we have handled empty linked list case. We have handled when we have to insert a new node at k is equal to 0. Still any cases left where I have to handle the code? Yes, everyone. There will be one more case. That case is what? That case is you are having the value of k and that value of k is greater than the length of the linked list, right? Length of linked list. Everyone is getting the point? Yes or no? So let's see that case also. Let's assume here in this example itself, let's assume this one, this one, this one. Let's remove this one, and okay, this is my linked list here, right? This is my linked list, and the length of the linked list is what? 5. And let's assume I have to insert a new node at index 8, right? So guys, you can see since the length of the linked list is 5, there will be never a 8 index, right? Yes or no? And what we are doing, we are saying for int I is equal to 0, I is less than k minus 1, I plus plus, right? And after that temp is equal to temp ka next, right? This one here, this we are doing, right? And right now the value of k is what? 8. So 8 minus 1 is what? 7, right? K minus 1 is what? 7 here. And right now my temp is what? It is pointing to the first node of the linked list, right? So here let's see now, I is equal to 0. Let's create this one, right? I is equal to 0, dry run table here, and 0 is less than 7. 0 is less than 7, that is true. And the moment the condition is true, you will move inside the body of the for loop, right? You will move inside the body of the for loop. And what we are doing, guys, we are moving to the next node, that is temp is equal to temp ka next. So from here, you will move to the next node, that is here. After that, again you will check the value of I will get incremented, right? Now the value of I is what? 1. 1 is less than 7, again it is true. Again you will move inside the body, again you will execute the body, that is temp is equal to temp next. You will move to the next index, right? After that, after executing the body of the for loop, you will move to the updation part. Again you will update the value of I, that is I is equal to 2. 2 is less than 7, again it is true. Again you will move inside the body, again you will execute this particular line, that is temp is equal to temp next, that is you will move to index 3 now, right? Index 3 here. After that, again you will check, that is I is equal to I plus 1, that is 3. 3 is less than 7, it is true. And you will move inside the body of the for loop, you will go to the next node, that is temp here now, right? Again, I is equal to 4. 4 is less than 7, it is true. Again the condition is true, move inside the body of the for loop. And temp is equal to temp next, that is now temp is pointing to the null node, right everyone? Now temp is pointing to the null node here, you can see. And again I will be incremented to 5. 5 is less than 7, it is true. And the moment it is true, you can see 5 is less than 7, it is true, right? And if it is true, you will move inside the body. And this time what we are doing, guys, temp is equal to temp next. And this time this temp is what? It is null only, right? Null next. So again, you can get a null pointer exception. So you have to handle this case. Everyone is getting the point. We have to handle this case also, right? So here what I will do, how to handle this case. First thing is what? I should be less than k minus 1. And I and your temp should not be equal to null. If it is null, then you will get a null pointer exception. So I will write these 2 points like this. Okay. And apart from that, this one here, right? So why I'm writing this I is less than k minus 1 and temp not equal to null. That means the moment I got a null, I will move out of the for loop. The moment the value of temp is null, I will not go inside the for loop because I will get a null pointer exception, right? And in that case, I will move out of the for loop and here I will write a check. If your temp is equal to null, right? If your temp is equal to null, in that case, in that case, you can't do any insertion, right? You can't do any insertion. In this case is what? If temp is equal to null, this case is your value of key is greater than the length of the linked list. And in this case, you can't do any insertion. So from here itself, you will return head, right? Now this is clear, everyone. Now guys, please give a thumbs up if this is clear. Arvind, you are facing the issue of attendance. Okay, try to answer each and every question that I am asking in the class. And if you are able to answer, or if you are trying to answer, I will note your name and I will mark the attendance and I will send the certificate to you also. Okay, Arvind, that will work for you? Yes? Yes, Arvind. So just give the answer in the chat. Okay, whatever question I'm asking you, and you will get the attendance, you will get the certificate also from my side. Okay, great. So now let's move to the next part, right? That is deletion, right? Now we have inserted at the kth index, we have done the insertion at tail, and we have done the insertion at head, right? Now let's move to the next part, that is deletion. This one here. Deletion in linked list, right? Deletion in linked list. Okay, this one here. So here we have the linked list. Let's assume we have a linked list here, right? That is this one here, this one here. Okay, let's assume this is my linked list here, and this head pointer is holding the address of the first node of the linked list, right? So the first case is what? Case one. That is, we have to delete the head node, right? We have to delete the head node, right? So guys, that is very simple, right? If you have to delete the head node, then what we will do, guys? Just move your head node from this particular node, that is from the start node, to the second node, that is here. So how you will move the node? That is, just do head is equal to head ka next, right? Yes or no? This is clear. Just move head is equal to head ka next. And now this head is pointing to this particular node, that is your second node. That means you lost the address of the first node, right? You lost the address of the first node here. This is clear. And guys, one more thing. See, in C++, see in Java, not in Java, in C++, let's take C++ only, right? We have two memory area, that is your stack memory area and your heap memory area, right? Heap memory area, right? And in the stack memory area, we have the stack, and in the stack, we have the stack frame, right? We have the call stack, inside the call stack, we have the stack frame, right? And guys, the variables, the local variables you are defining inside the stack, the variables, the data structure you are defining without using the new keyword, all those variables, all those data structure, the memory gets allocated where? Inside the stack itself, right? So in stack, what happened, guys? If you are not deleting the variables, if you're not deleting the data structures, so it gets automatically deleted when the scope of the variable, when the scope of the data structure is finished. Everyone is getting the point? So whatever variables here, whatever variables, whatever data structures you are defining inside the stack, these variables, these data structures get deleted automatically when the scope of the variable, when the scope of the data structure is finished. Okay, but if you are creating, like if you are creating any variable, if you're creating any data structure, and for those variable, for those data structure, if you are allocating memory inside the heap, how to allocate memory inside the heap? With the help of a new keyword. So if you are allocating memory inside the heap for your variables and for your data structure, so in this case it is not automatically gets deleted. You have to delete it. You have to take the responsibility of deleting it. So you have to manually delete it. Everyone is getting the point? Yes or no? So we have to use a delete keyword, right? Delete keyword here to delete the memory inside the heap. Okay, this responsibility we have to take it, right? In case of stack, if the memory is getting allocated inside the stack, then there is no responsibility we have to take. That will automatically gets deleted when the scope of the variable, the scope of the data structure is finished, right? That is clear. And guys, in Java, this deletion, the deletion of the memory is taken care by your Java collector. So in Java, we don't have to use any delete keyword and any other keywords. It is automatically deleted by your Java collector. Sorry, not Java collector, garbage collector. Okay, this is clear. So here also, guys, you can see what we are doing here. This one. Hmm. So what we are doing here, guys, you can see we are moving our head to the new node, that is to the second node, but we are not deleting it, right? So for this node, that is for the first node, the memory will be there inside the heap, right? The memory will be there inside the heap. You are consuming memory, right? You are wasting your memory. You have to delete it, right? So somehow you have to do the deletion. How to do the deletion? You have to store the address before moving the head. Before moving the head to the next node, first store the address of the start node inside the temp variable. And after that, with the help of delete keyword, delete the temp node, right? This is clear. So let me write the code. You will get the more clear understanding, right? That is here, this one. Node star. Okay, after deleting it, you have to return the start address, start node address of the linked list, right? That is node star delete at head. And here you are getting what? You are getting the address of the head node, right? So in order to manually delete it, first you have to preserve the address, right? Before moving your head to the new node, preserve the address, right? That is node star temp is equal to head. After that, what you have to do, just move it, right? Just move your head to the next position. That is head is equal to head ka next, right? Yes or no? This is clear. You're moving your head to the next node, right? And after that, you can use a delete keyword to delete the temp node that is defined inside the, to delete the memory that is defined inside the heap area. This is clear. Okay. After that, this one here. Hmm. After that, you will do what? You will return the head from here, right? You will return the head from here. Okay, this will work. And one more thing, guys, right? See, this code will work. But what if my linked list is empty? In that case, there is nothing to delete. And if there is nothing to delete, this head connect will give you null pointer exception. So you have to explicitly handle this null pointer exception wala case. That is when your linked list is empty. That is if head is equal to null. In that case, your linked list is empty. And in that case, what we will do? We will do nothing here. We can return your head as it is, right? Okay. Please write in the chat if this is clear. Yes, everyone. This is clear now. Please write in the chat if this is clear. Yes, no. Yes, everyone. This is clear now. Okay, great. If this is clear, guys, can you just write in the chat how many number of iterations we are taking here? How many number of iterations we are taking here? Or if you know about the time complexity, what will be the time complexity here? Yes. So guys, in this case, you can see we are taking constant number of iterations. There is zero number of iterations, right? Yes or no? So your time complexity will be what? It will be equal to big O of 1. That is constant here, right? That is clear. So now let's move to the next part, that is delete at tail, right? Delete at tail here. So we have the linked list here, right? This one, this one, this one, this one, and this one, right? And after that, what we have to do? This time we have to delete the last node of the linked list, right? We have to delete the last node of the linked list here. So guys, right now I know the head node. I know the address of the head node, right? This one here. So what I will do now? Anyone? What I will do? Okay. So in order to delete this one, right? The address of the last node is stored where? It is stored inside the next node, in the second last node, right? The address of the last node is stored inside the second last node, right? So what I will do? First, I will break this connection, right? After breaking this connection, I will use the delete keyword to delete this particular node. That is your last node. This is clear. And now I know with the help of this while temp next not equal to null, right? With the help of this condition, I will stand at the last node. If I'm standing at the last node, what I will do, guys, I will create one more pointer, and that pointer, what I will do, I will point to the second last node, right? So now I know the address of the second last node. I will just put null inside the second last node, and after putting null inside the second last node, what I will do, I will delete it directly, right? I will delete the last node directly here. Yes, everyone, this is clear. So let's see now how to write the code for this one. That is node star delete at tail, right? And we are having what? We are having the, so this one node star head here, right? And after that, after that, what I will do, I will preserve the address, right? So I have to create two pointer, right? One to move to the last node and one to move to the previous one. So I will preserve the address of the head node, that is node star temp is equal to head here, right? That will preserve the address of the first node. After that, I will create one more variable, that is your previous, right? Previous here. And this previous is currently pointing to null, right? Like this. So what I have done here, I have created one variable temp, and that temp is pointing to the start node. And right now there is no previous node, so previous node is pointing to this, previous pointer is pointing to null. Inside previous, null is stored, right? After that, what I will do, this one here, I will use a while loop, right? And this while loop will execute till the time your temp is temp next, right? Temp next not equal to null, right? Till the time temp next is not equal to null, till that time I will execute the body of while loop. And basically, guys, what we are doing in the body of while loop, we are moving my temp to the next node, right? Temp is equal to temp next, right? Okay, and before moving, guys, right, before moving your temp to the next node, first store the address of your temp inside your previous, right? That is previous is equal to temp, right? This is clear. That is what I have done here. That is, you can see before moving this temp to the next node, what I'm doing, I'm updating my previous to temp, and after that I'm moving the temp to the new node. And this process will follow until this temp is pointing to the last node. The moment your temp is pointing to the last node, then this previous will automatically points to the second last node, right? This is clear. And after that, what I will do here, right? I will I will break the connection between the second last node and the last node. That is previous connect is equal to null, right? Previous connect is equal to null. That means first I am breaking the connection. After that, what I will do? This one here. After this, I will delete, right? I will use the delete keyword to delete the last node. That is delete, and the last node information is stored where? Inside the temp pointer variable, right? So delete temp here, right? Great. Everyone, this is clear now? Please write in the chat if this is clear. Yes, no? Okay, now this is clear. Okay, we have to handle one more case, guys, right? We have to handle one more case, right? What case? Again, this case, right? That is, if your head is null, right? That is, your linked list is empty. In that case, you don't have to do anything, right? Just directly return head from here. And from here also, after deleting the last node, just return the head, right? This one here. And one more thing, guys, right? That is return head. That will work. Okay. Still, we are missing something. Anyone? Rachit, still we are missing something. Okay, Rachit Garg. In this code, if you will tell me if we are missing something, you will get the attendance right now. So Arvind, you will get the attendance, okay? I will talk to the management and you will get the attendance. What about Rachit, you? If you will tell me what is missing in this code, you will get the attendance, okay? There is no need to manually write the attendance. Yes, Rachit. Just tell me if we are missing something. Yes, no. If we are missing something, then what? If we are not missing anything, then just write no. Yeah. Anyone? This is clear, right? Still, we are missing something here. That is, what if we have only one node present in the linked list? Only one node. That is your head node, right? And if we have only one node present in the linked list, then in that case, guys, in that case, you can see what will happen. Temp connect is not equal to null, this, previous connect. So this previous will become null, right? What we are doing here, we are saying, okay, according to our logic, we are saying, okay, this previous is pointing to the second last node. And if there is no second last node, if we have just one node left, right? Yes, if we have just one node left, that is, 1 minute, like this case here. Okay, that is, we have this one node, single node in the linked list. In that case, your previous is what? It is pointing to null, and this is your head, and this is your temp also, right? And in that scenario, in that scenario, guys, you can see you will not go inside the body of the while loop, and this previous will be null. Null ka next is equal to null. That is, again, you will get a null pointer exception. So you have to handle this first node, that is when there is one length linked list explicitly. How you will handle? Here itself you will handle it, right? That is, hey, uh, now I have to just change a bit of a code here. That is, head is equal to null, or head ka next is equal to null, right? If head is equal to null, or head ka next is equal to null, that means either zero node is present or one node is present, right? And in that case, guys, what I will do? First, I will delete the head, right? Delete the head, and after that, return null from here, right? Yes, this is clear now. Everyone present in the class, now this is clear. Yes. So let's move to the last delete operation. Last delete operation, that is, we have understood how to delete at the head, how to delete at the tail. Guys, can you tell me now, in this delete at tail, how many number of iterations we are doing here? Everyone present in the class, how many number of iterations we are doing here in the delete at tail? Please answer in the chat. Let's see. Manoj is saying no, sir. What no, Manoj? How many number of iterations? Yes, sir. That node is null is equal to null. Sorry, Arvind, you're saying something. I guess not able to understand. Can you please clarify that part? It is not big of one again. It is not big of one. It is how many number of iterations, guys? Here you can see we are using a while loop, right? While loop, and inside the while loop, basically what we are doing, guys, we are traversing the linked list. Okay, and in the worst case scenario, we will traverse the whole linked list, right? If there is any test case where, see, in the delete at tail means what? You have to delete the last node, right? Last node means what? From the head node, you have to traverse the whole linked list. So the number of iteration is what? It is equal to the length of the linked list. That means the time complexity is your big O of length of linked list, right? That is clear. Yes, everyone. The time complexity is clear. Can you please repeat at once? What to repeat at what point? I have to repeat. This is clear, right? That is 107. Part is clear. It is not log. Again, it is not log. Surya. Simple, right? If you are standing here at the first node, in order to delete the last node, you have to traverse, right? You have to traverse. And how many times you are traversing? How many times you are executing the while loop? That is equal to length of the linked list, right? Great. So can you please repeat once? Footage pro, right? What to repeat? Any part you're not able to understand, I will repeat that part. Please write in the chat, okay? Correct. It is big O of n. N is what? The length of the linked list, okay? Great. Constant number, that is zero. Sorry. What is this constant number here? Constant number, that is zero. Not able to understand your point, Arvind. Why you are writing this constant number that is zero here? Okay. Till that time, we are moving to the next problem statement. And yes, Those guys, those who are not able to understand any part of the code here, you can write in the chat. I will explain it again, okay? Okay, okay. Okay, Arvind. Great. So now let's move to the last part of the code, last part of the question here. That is what we have to do. Delete at kth index, right? Kth index here, right? So here, delete at kth index is what? Now you have to delete the element at the kth index, right? So here, let's assume you have this linked list. That is this one, this one, this one here, and this one, and this one here, right? And let's assume this indexing is what? It is zero based indexing. And let's assume you have to delete this k is equal to 2, right? K is equal to 2 is what? This is 0 index 1, 2. So you have to delete this particular node, right? You have to delete what, guys? This particular node, that is at index 2 node, right? Yes or no? So guys, tell me where I should stand. Where I should stand. I should stop at, like, I should stand at index number 1, or I should stand at index number 2. Please write in the chat. See, English is all about connections. Okay, connections and information, from which particular node you are getting all the information, and from which particular node you can do the connections and remove the connections. Okay, it is just connecting and disconnecting it, right? Correct, correct. We should stand at index number 1, not at index number 2. Everyone is getting the point. Why? Here you can see, if you will stand at index number 2, then you can see, guys, we have to delete it, this one, right? Deleting this index number 2 node means what? We have to connect index number 1 node with index number 3 node, right? That is, if this is k, then we have to connect this k minus 1 index node with k plus 1 index node, right? This connection we have to do it, right? So if I'm standing at index number k, right? If I'm standing at index k node, then guys, I know the information of k node, I know the information of k plus 1 node, but I don't know the information of k minus 1 node. Everyone is getting the point. I don't know the information of k minus 1 node. There is a way, like I can use a previous pointer concept and I can store the information, but that will make your code more complex. Always when you're writing the code, try to make the thing as simple as possible. Try to use as simple variable as possible, right? As less number of variable as possible. So here also, if I'm standing at the kth node, then it is not possible for me to access this k minus 1 node. But if I'm standing at this k minus 1 node, then guys, you can see I can access this kth node also, because inside this k minus 1 node, it is storing the address of the kth node. And if I'm able to access the kth node, then that means I will be able to access the k plus 1 node also. Everyone is getting the point, because inside the kth next part is storing the address of k plus 1 node. Everyone is getting the point. So we have to stop at this particular point. We have to stand at k minus 1. So I will just do what? I have to make this particular connection and I have to delete this kth node, right? So let me write the code. You will get the more clear understanding here, right? That is node star, that is your pointer here, right? We have to, after deleting it, we have to return the head of the linked list, right? That is node delete at k index here, right? And after that, what I will do here, I'm getting this information of the head node, that is node star head, right? And after that, I have to write the code, and we are getting the k also, right? Where I have to delete it, right? This one here. So here what I will do, see, always preserve the address of the first node. How to preserve the address of the first node? By creating a new pointer that will hold the address of the first node, that is your node temp is equal to head here. After that, what we will do, guys, we will use a for loop that will start from, since it is a zero based indexing, so int I is equal to 0. It is similar to the insertion at the kth index. The same code The same for loop I will write here, right? This one here. Okay. So let's copy this for loop from this one here, right? Insert at kth index and let's paste here, right? This one here. Okay. So with this for loop, we will be able to stand at the k minus 1 index. That is clear. And this for loop is handling this temp is equal to null wala case also, right? And here, first what I will do, guys, if your temp is null, if the value of k, the element, the node you have to delete is greater than the length of the linked list, the index is greater than the length of the linked list, then nothing you have to do, right? In that case, that is if temp is equal to null, right? That means there is no node you need to delete. So you can directly return head from here, right? Return head from here. And after that, if this condition is not true, right? If this condition is not true, that means you have to do the deletion. So what you will do the deletion, that is temp is equal to temp k next ka next, right? Temp k next ka next. This is clear. That is temp k next ka next. So right now, this temp is what? This one here, you can see, guys, this is your linked list. So index 0, 1, 2, 3, 4, 5, right? And you have to delete k is equal to 2. That means this temp is pointing to k minus 1, that is index number 1. So temp ka next is what? Temp ka next is this node 2, right? Temp ka next is node 2, and temp ke next ka next is what? It is the address of node 3, right? So you are connecting this temp ka next, right? Temp ka next here with temp ke next ka next. That means you are making this particular connection, right? You are making this particular connection. Everyone is getting the point? Okay. And one more thing, guys, before making this particular connection, first preserve this address so that you can delete it manually, right? So here what I will do, that is okay. So here what I will do, first I will preserve the address, right? That is what I will do here. Before doing this part, first I will preserve the address, that is node star to delete. Let's assume I'm creating one pointer. The name of the pointer is to delete, that is preserving the address of the node that we want to delete, right? Is equal to temp next. And after doing the connection, now I will delete it. That is delete to delete, right? This one here. And after that, I will return from here, return head from here. This is clear. Everyone present in the class, this is clear. And again, we have to handle this empty linked list case also, right? That is if the linked list is empty, that is here. That is if your linked list is empty. That means the same case where we have handled here also, right? If your head is null, then we have to return nothing, right? That is if head is null here, then return what? Return null, right? There is no need to delete anything, right? Okay, great. And anything else we are missing here? And this. Okay, this code will work for everything. And yes, we have to handle this case also, right? That is I is equal to 0. This we are doing here, right? Temp is equal to head. This one here, right? Okay, great. And this code will not work, right? If the value of index is 0, right? This code will not work if the value of index is 0. That is, if the value of index is 0, that means temp is here, right? Temp is here, and this node I have to delete. Basically, guys, what we are doing, we are making this particular connection. So if the value of temp is 0, that means we are deleting this particular node, and this is not the correct way, right? What we have to do, we have to handle this case also explicitly. So what I will do here, if your k is equal to 0, right? Then we have to delete the head node. And when we have to delete the head node, what I will do, I have written the logic here, deleted head. I will call this particular function, right? If k is equal to 0, call this particular function and pass the head, right? And after that, return from here. Okay, everyone is getting the point, yes or no? Please write in the chat if this is clear now. So guys, whenever you're dealing with a English question, okay, always try to create a diagram, right? Always try to create a diagram and always try to connect your node and disconnect your node with the help of diagram, so that you get the clear understanding where you have to stand, where you have to stop your for loop, okay, what all cases you have to handle. And always try to like whenever you're dealing with the English question, always try to keep this thing in mind. Okay, what will happen if the English is 0, right? There is no node present in the English. What will happen if I am standing out of the bound, that is if I am standing out of the index length, right? What will happen then? So you have to ask this kind of question to yourself, right? And English is one of the simplest topic, and guys, this is one of the most asked topic in the interview also. So whenever you're getting the chance, just understand these concepts. This is a basic concept, and yes, like you will be able to do good in the interview. Okay. Okay, attendance, everyone is seeing attendance. So you will get an attendance link, right? 1 minute, let me check with the management. uh, and guys, this is all for today's session. Please give a feedback, okay? Whatever you are liking in this session, please give a feedback in the chat section, okay? And whatever you're not liking in the session, please give a feedback, okay? Because feedback is very important for us to improve, okay? Because we are, like you can see guys, we are doing a lot of hard work, right, to give you the best content. So if you have any feedback related to the communication, relating to the teaching method, related to the content, anything guys, okay, always try to interact, okay? Always try to put in the chat your suggestions, and according to that we will improve, okay? Great. And please like the session also, so that we get the motivation, and your friends and everyone can like watch this session and get the clear understanding.